Okay, today we're talking about Chapter 6, Section 3, more of the metric system, but this time we're going to be talking about capacity and weight. So last time we talked about length. Today is capacity and weight. I know, so let's just see if I can just snip all of this. Go there. All right, so in the last section we talked about, again, length, and we used the words like milli, centi, hecto, kilo. And we're going to do that again here. And that's what makes the metric system so much more convenient. And again, it just makes so much sense. And I don't know why the United States is just, they're not willing to make that conversion. And of course, I mean, I say that coming from someone who honestly doesn't even, I don't even try to because, well, what's the point? Everybody else uses the American system. But the metric system is so much easier, so much easier to convert. Um, the words are used very similarly, and well, let's just continue it before I go off on a tangent and I forget what the heck I'm talking about. So the metric system, capacity and weight. Whenever we talk about liquid volume, we talk about it in liters, and the liters is going to be our unit of measurement here, kind of like how meters was for our length. So 1 liter is going to be our unit. Well, a milliliter is going to be a thousandth of a liter. A hectoliter is going to be 100 liters, and a kiloliter is going to be 1,000 liters. And so we're going to do this conversion the same way that we did meters in the last section. And today should be a pretty short lecture. It's pretty easy stuff. And just put 2 and 3 there as well. There's not much computation to be had, so realistically, I think it's just easier if I just talk through it as opposed to writing things everywhere. So, starting with example 1 here, we have the common metric units of capacity. So, choose the best metric unit of capacity to complete each statement. A jug of orange juice might hold to what? Well, it says choose the best metric unit for capacity. Well, it might hold 2 millimeters, or I'm sorry, milliliters. Not really. Kiloliters, again, kiloliters is 1,000 liters. Well, obviously it should be pretty easy. It's just 2 liters, right? We're talking about a jug of orange juice. So flushing a dog's eye with saline solution requires 10 blank of solution. Well, we don't want to use, this is a really silly problem. We don't want to use 10 liters of solution. That's a lot. Obviously, we don't want to use kiloliters. All right, so we're going to be using 10 millimeters of solution. All right, just choosing the best metric. Now, of course, you control that answer on the homework, and well, you'll get it wrong. But I guess it's just a common sense check. I don't know. So 2 and 3 are going to be pretty much what we did in the previous section. One being using our conversion length here, and the second one being our using our metric conversion line. So 1.4 liters to milliliters. We know that 1.4 liters. All right, we're going to multiply that by 1,000 milliliters over 1 liter. Again, this is done to cancel the liters, and then it's just 1.4 times 1,000, which is 1,400 milliliters. And again, this is to me it is easier. It's just the way the book goes about it is a little. I don't know. It's not my favorite. But if we want to convert 2.5 milliliters to liters using the metric conversion line, again we have our metric conversion line here, and we have well we have our big our larger units over here to the left are smaller to the right, and that's done on purpose. Different than what we're used to on a number line, right? On our number line, well, on a graphing number line, the small numbers are to the left and the large numbers are to the right. But this is backwards, mainly to show how we move the um, decimal units. Okay, so in order to get from milliliters to liters, we need to move our decimal point 3 points to the left, and so we go from 2.5 milliliters. We move that decimal point 3 to the left to get to 0.0025 liters. Okay, so again, the whole point of that is just to be able to move that decimal point and really fully understand uh, how that's done. 4 is combining them, so let's go ahead and snip that as well. And we'll go ahead and put 5 there on the same page. Like I said, uh, the good thing about metric system is, I mean, once you do it once, you've done it. You've done them all. So I don't feel too bad just snipping this because of that reason. So converting metric units of capacity. So we're going to convert 3.65 liters to milliliters. A, we're going to use a unit fraction, and the B, we're going to use the metric conversion line. Okay, so the unit fraction is, the first method where we do canceling, and the second method is going to be the number line. Same thing for example 5. Okay, so 3.65 liters to milliliters. Same thing, you want to have the liter in the denominator here, so you can cancel it, and then it's just 3.65 times 1,000, or 3650 milliliters. And the better way, again, what I think, the better way would be to use the metric conversion line. Well, we start with the original, which is a liter, and then we have, of course, we have deci, centi, and then milli, which is 3 units, right? And if we're going from liters, we're going from liters to milliliters. Well, it takes us 3 units to get there, so we're going to take the decimal point and move it 3 units to the right. And of course, we get the exact same solution there. Same thing over here. A ball bearing displaces 6 milliliters of water. So convert this amount to liters. Okay, well, same procedure. You want to have 1 liter is equal to 1,000 milliliters. Cancel the milliliters. Then you have 6 divided by 1,000, or 0.006 liters. And again, the better way, I think, is using the metric conversion line. We're starting at milliliters. We want to get to liters. Well, that is 3 units away. We go from milli to centi, centi to deci, deci to liters, or deci to the unit measurement. That's 3 decimal places to the left. So we take that 6, and then we take the decimal point place and move it 3 units to the left to get to 0.006. And again, that's very hand wavy, I know, but I feel like we've done these problems a lot, especially last section and into this section. So hopefully it's definitely in your head. All right, I'm pretty sure mass would be the last thing here. Yeah, mass is the last thing we talk about here in this section. And, well, it's about as easy as everything else so far. And what I mean by that is, let me see, let's try it again. You just have the unit measurement, all right? The unit measurement here is going to be gram for mass, and you use the same prefixes that you do for honestly everything else here. Okay, so looking down here, the gram is the unit of measurement, and the smaller we go, deci, centi, milli, we get to, again, the same thing as 0.1, 0.01, 0.001, and then deca, hecto, and kilo, same thing, 10, 100, and 1,000. And of course, a metric ton is 1,000 kilograms, which is actually pretty interesting. That's just a nice little side point here. If you've ever heard somebody say metric ton instead of ton, well, a metric ton is 1,000 kilograms, whereas a ton that we're familiar with is 2,000 pounds. Okay. And it's going to be another one of those, kind of common sense problems, which I think are kind of fun. Um, and if I was a student, I'd be like, man, I want more of these because, well, I don't know. Seems pretty easy to me. Put that over here, and let's see if we can just put 7 and 8 in here as well. Yeah, 7 and 8 are just going to be the exact same thing we did in the previous ones. Put example 6 right here. Oh yeah, we have plenty of room. example 7 here, and then we'll put example 8 down here. Alrighty, so let's finish up this section really quick, day to day. So example 6, common metric units of weight. So a piece of paper might weigh 4.5 what? Well, I mean, we're talking about a piece of paper here, and now that I think about it, it might not be the most obvious uh, answer, only because many people don't really know how much a gram weighs. Okay, well, gram is used as a as a weight filter for paper, at least for like resume paper and stuff. It is used, grams is used to measure that. So we say a piece of paper might weigh 4.5 grams. All right, and then a container of cheese might weigh 0.5 what? Well, a container of cheese might weigh 0.5 kilograms. Okay, and I think that seems a little bit easier than grams. Again, only because, and I'll be honest with you, I don't think I really know how much a gram is. I mean, I do. I mean, I've used it. I've used them in my science courses where I've had to measure things. But I mean, if I held something that was a gram, I don't know if I would say, hey, this is 3 grams. That's it. Okay, so um, lastly, we're just going to do this 7 and 8, kind of how we did one of the first two examples before. Um, we're going to first use the unit fraction and then the metric conversion. So 34 grams to milligrams. Well, we know that there are 1,000 milligrams in a gram. I want to cancel my grams, so 34 times 1,000 or 34,000. And then the easier way, again, would be looking at the metric conversion line. I know that the milligram is way over here, and I'm trying to get to a gram. Um, well, no, I'm sorry. We're trying to go from grams to milligrams. Okay, so we have to move our decimal point 3 places to the right, and of course we see that down here with 34, 0.0, and we take that decimal and move it 3 places to the right to 34,000. Over here we have a box of detergent weighs 475 grams. We want to convert this mass to kilograms, and so same procedure again ad nauseum here. 475 grams. Well, I want to change it to kilograms, so I have to say 1 kilogram is over 1,000 grams. They're equivalent. I cancel out my grams, so it's just simply 475 divided by 1,000, or 0.475. And again, if you don't want to do all that, there's nothing wrong with it because we know that we're going from grams to kilograms. Well, that is 3 units to the left, so we take the decimal 475.0, we take that decimal and move it 3 places to the left to get to 0.475 kilograms. And just make sure, yes, that's it. And that concludes today's lecture.